All right, let's solve another example. This time it is question 8 from page 31. Let's read the question. Question 8. In the figure, we have a charge of 3 microcoulomb located at x is equal to 0, and a second charge of 2 microcoulomb located at x is equal to 2 meter. Where should we place a third charge such that the net force on that charge is 0? First, let's draw the diagram. We are given two charges. We are given the first charge, I'm going to write it Q1 at x is equal to 0. Q1 is equal to 3 microcoulomb. There's a second charge 2 meter farther away at x is equal to 2 meter. That second charge has a charge of 2 microcoulomb, and I'm going to denote it as Q2. Now, we want to find the location where we could place a third charge such that the net charge is 0 on that charge. We are going to call that charge Q3. Now, on this axis, there's 3 locations really we could consider of where we could place that third charge. And I name it this location 1, 2, and 3. So we are going to have a look at how the force diagram will look like if we were to place the third charge at the first location, the second location, or the third location over here. All right, and we're going to assume the third charge is positive, although if we add the negative charge, the result will be identical. All right, it's just that all these force vectors we are going to consider in an instant will be pointing in the other direction. All right, so let's consider the first location. Here, if we place a positive charge, the first charge will repel the third charge. So F31, and I'm missing an arrow over here. Actually, I'm missing an arrow on all of these. There we go. So F31 is pointing to the negative x direction. The second charge will be again repelling the third charge and pushing again the negative x direction. If we look over here, both forces are pushing in the negative x direction. In other words, there's no way for these to add these force and get the net force of 0. In fact, we will see in an instant, to get a net force of 0, they absolutely need to be pushing in opposite direction. So let's consider the second location now. The second location over here, if we place again a positive charge over here, the first charge and the third charge will apply a force on the third charge, pushing in the positive direction. So F31 is pointing in the positive x direction. The second charge will be pushing the third charge in the negative x direction. Therefore, it will be pointing in a negative direction. So we see here that in this format, it is possible to select a location where these two forces could cancel out each other. All right, we're going to see the math in an instant. And the third location, well, really, this is just a mirror image of the first location. Both forces are pointing in the positive x direction. There's no way they will cancel each other out. All right, so let's redraw the original diagram with Q1 and Q2, and now we know that Q3 has to be somewhere in between. All right, the next thing we're going to write on our diagram is x1 and x2. x1, actually, just to remove some confusion, I'm going to call it x13, x23, and this will be the same logic down here. So basically, x13 is the distance between the first charge and the third charge. x23 is the distance between the third charge and the second charge. All right? Now, in this case, as we've seen on the force diagram, the force applied from the first charge on the third charge will be pushing in the positive x direction. The force from the second charge on the third charge will be pushing in the negative x direction. So net force has to be equal to 0. It's equal to the force of the second charge on the third charge plus the force of the first charge on the third charge. And that means these two has to be equal, but pointing in opposite direction. All right. Now, we know, looking at this, that they are already in opposite direction by the force diagram. So we can now write these formula as such. These are the Coulomb force constant, and we have on both sides we have the Coulomb constant. On both sides we have the third charge. What changed is Q1 on the left side, Q2 on the right side, and we got X13 on on the left side and x23 on the right side, okay? I will need some more space in order to continue the algebra step. So if you need to write anything down, you can pause the video now. And I'm gonna erase that part. I need some more room. All right. Now, actually I don't need that part also. All right. Now, if we look over here, and I'm gonna run an arrow over here because we are going to restart here. We can cancel out the Coulomb constant on both sides. We can cancel out Q3 on both sides. They are not needed. And I'm gonna flip x13 square on the right side and flip Q2 on the left side. So we have Q1 divided by Q2 is equal to x13 square divided by x23 square. Now if we look, Q1 is 3 microcoulomb, Q2 is 2 microcoulomb. The ratio of these two is simply 1.5. All right, now we have a problem. We have one formula, two unknown. We need a second formula. Well, at the beginning of the problem, we've been told that the distance between, well, we're not being told the distance directly, but we have been told the location on the x-axis of the first and second charge. And we can see that this one is at x equal to 0. This one is at x equal to 2 meters. And basically the distance between the two has to be 2 meters. So in other words, x13 plus x23 has to equal 2. All right. Here, we can isolate these values and replace one of them over here. So what we have, if we combine that formula over here, we can square root both sides. So we have x13 is equal to x23 square root of 1.5. We replace that term over here. We replace x13. So we have x23 square root of 1.5 plus x23 is equal to 2. Again, I need more room, so I'm going to erase the bottom part. And just to make sure everything is correct, let's compute this value. So we got square root 1.5. So we get x23 is equal to 0.9. Well, since x23 and x13 has to equal 2, we can easily find that x13 is equal to 1.1 meter. Don't forget the unit also for that one. This is really the value on the x-axis. Now remember this one, x23 is 0.9 meter, but it is the distance from the second charge to the third charge. It's not exactly the position on the x-axis. This one is exactly the position on the x-axis. So it's at 1.1 meter, all right? So that's it for question 8. Let's go to another video and solve some more example related to this. All right, see you in the next video.